Okay, so once I've got my period shortened to 2 pi, it means it's going to go max to max in 2 pi over 3. Halfway in between that, it's going to have its minimum. Halfway between the max and the min, it's going to hit a 0. Halfway between the min and the max, it's going to hit another 0. So basically, I just shorten my cosine to be fitting within 0 to 2 pi. Questions about that? All right, now you can choose to do your amplitude and your reflection in 2 steps, or you can do it in 1. That's up to you. That 2 is going to change the amplitude of my maxes. It's going to make my maxes up at positive 2 and my min down at negative 2. But that 2 is also negative. Whether we write it down for the amplitude or not, you do have to do a reflection. So what I am thinking of in this is kind of 2 parts. I'm thinking that max stretches up to 2 and it reflects over the x-axis and becomes a minimum. This minimum would flip and become positive 2. This maximum would flip and become negative 2. So it takes my cosine graph and it flips it upside down and it stretches it at the same time. Now, if you need to do that in 2 steps, do it in 2 steps. This is a great one for, like, I would not want you to fill this whole graph because they're so close together. That's just annoying. Okay, I would do 1 rotation from here forwards and 1 rotation from here backwards. Each of these points are only 1 block apart. So I can continue going 1 block over, back to 0, 1 block over, up to 2, 1 block over, back to 0, 1 block over, down to the minimum. And do the same thing going backwards, which would look like, these are kind of like satisfying to connect the dots on, I'll be honest. It's a little bit weird, but it's okay. My graph might look something like that. Again, does any of that change my domain? Nope. My range, though, for this would be what? Negative 2 to 2. Okay. Are we all okay with that one? Yes, no, maybe? Okay. I'm going to move to 3. Huh? And I'm going to move down.
Why did we start at negative 2 instead of positive 2?
All right, so on 3, what's my amplitude based off of my equation? 4. Now, period is usually 2 pi divided by b. What does that mean for us when our b value is a fraction? Multiply by the what? Reciprocal. So I take my 2 pi, and instead of dividing by 1/2, I think about it as multiplying by 2. What does that make the period of the function? 4 pi. All right, here's going to be the issue with this one. Rather than this making it smaller, what is this doing? Making it bigger. All right, so let's look at what that's going to look like. So for this one, you guys are going to get to see this in like my video recording. It's not going to work out real well because I have to draw on the board for it. But I would start with my normal sine graph. So my normal sine graph, and I know it's a sine just because that's what it says, right? My normal sine graph is this. Rather than finishing that full rotation in 0 to 2 pi, it's now going to finish that full rotation in 0 to what? 4 pi. Now, some of you are going to see this kind a little bit easier, and some of you are going to make faces at me, and that's okay. Okay? You do not have to extend out to 4 pi to do this. You can just say what section would fit in 0 to 2 pi and then go backwards. But some of you are going to need the visual of what it would look like out to 4 pi, so I'm going to show you that on this first one so you get the idea. All right? So if I continued my graph out here, and I'm going to run out of room, but I'm going to just say this is 4 pi over here. Okay? We're going to say it's 4 pi all over here at the end. Rather than my graph fitting in 0 to 2 pi, it's going to fit 0 to 4 pi. So it's going to go all within that. So that means if I'm splitting my graph up evenly, that other 0 is halfway between those. Where would that be? 2 pi. The maximum would be halfway between the first 2 points, which would be where? Pi. The min would fit where? 3 pi. Okay, now again, you do not need to show that right-hand side as long as you can think of, okay, if I'm stretching it, then it's just going to go up to the max and back to 0 and 2 pi. What do you think that means it's going to do on the left side?
Go down.
It's going to go down and come back in 0 to negative 2 pi. So rather than drawing out to 4 pi, you can do the positive side in 0 to 2 pi and the negative side in 0 to negative 2 pi. What's that 4 going to do to it? The 4 is going to stretch the height. So it's going to take my maximum here up to 4. And it's going to take my minimum here down to negative 4. So this would be my final graph. That's usually the hardest one for us to see visually. Y'all are either quiet or handling it better than first period did. Just quiet today. All right, our last example on this will be number 4. Again, that doesn't change my domain, and it would just make my range negative 4 pi, or negative 4 to 4. What's the difference in question 4? There's one more different way I can present these. There's a pi in the b. Yes. Now, you will notice, since there's a pi in the b, take a look at the graph. Oh, there's ones. Yes, there's real numbers, not pi's. So let's see what that b value does for us. Okay? So what is the amplitude of my graph for this one? 3. I'm going to use that negative as a reflection in a minute, but we're not worried about that yet. Again, period is typically 2 pi divided by b. This one I'm going to actually show my work for it because the b's got a pi in it. Let's see what happens to it. If I am dividing by a fraction, it's the same as multiplying by its reciprocal. So if I multiply by 4 over pi, someone tell me what's going to happen to my pi's? They're going to cancel. And that's going to make the period of this graph what? 8. Which is why the graph is labeled differently. Because it wouldn't make sense for it to be in pi's if the period is 8. Essentially, the b value being that eliminates the need for the pi's. So, let us think about what our normal cosine graph looks like. It's a little bit hard to graph it originally on this one because I don't have pi's, right? So let's think about the parent function for cosine. If I just drew myself a little sketch, my parent function for cosine does this. Maximum to 0, negative, back up to the maximum, right? That happens in 0 to 2 pi. This time we want it to happen in 0 to what? 0 to 8. This might be one where I do draw a little extension off of here. This is 7, so I might say this is 8 here. So if I want it to go 0 to 8, that means it's going to be a maximum at 0, and it's also going to be another maximum at 8. Halfway between those maximums is going to be my what? Minimum, which will be at what number then? What's halfway between 0 and 8? 4. Halfway between 0 and 4 will be my 0. Halfway between 4 and 8 will be another 0. Now let's use that amplitude. The amplitude is 3. So if you want to do this in 2 parts again, you can do that. You can stretch it up to 3 and down to negative 3 and then do your reflection from the negative, or you can do it in 1. If I was doing it in 2 parts, this one and this one would go up to 3 first. This negative one would go down to negative 3. And then I would do my reflection, which would make those maximums, minimums, and the minimum a maximum. So my final points would be these guys, if I erase my original stretches that I just did. Okay? So now I obviously can't continue forwards. I can continue backwards though. If I went backwards, it would go back to -2, back to 0, -4, up to 3, -6, back to 0, and I'd just probably stop there because I filled the graph. Connect my dots. Okay? Questions about that? Yeah.
So the thing that makes it reflects the negative